So in this video, we're talking about using our right triangle ratios if we're given a point on the coordinate plane. Now, before we go any further, that point cannot be the origin, so it cannot be 0, 0. And the point that we need has to live on the terminal side of our angle. And also, our angle always has to be in standard position so that our initial side is always going to be the positive x-axis. If all those conditions are met, then all 6 right triangle ratios can be redefined. For instance, sine is going to be the y-coordinate divided by the r, our radius. Cosine is going to be defined as our x-coordinate divided by our radius. Tangent is going to be our y-coordinate divided by our x-coordinate. However, x cannot be 0 for this one to work. Cosecant is going to be the radius divided by the y-coordinate. Again, y cannot be 0. Secant is the radius divided by the x-coordinate. X cannot be 0. And then the cotangent is simply the x-coordinate divided by the y-coordinate. Y cannot be 0. Here, the radius of our circle, because as we spin over and over again, we're making complete circles. The radius is just simply given to us by the Pythagorean theorem. Instead of a squared plus b squared equals c squared, we now have r is equal to the square root of x squared plus y squared. And that, again, that x and y comes from our point that lives on the terminal side of our angle. So let's do an example. Here I give you a point, 3, -4, and it's on the terminal side of some angle theta that's in standard position. We want to do these 6 right triangle ratios for this angle theta. Okay? So what I first need to do is figure out my radius. So I'm going to start off with, to find the radius, I know I have my x, comma, y. And I'm just going to use the Pythagorean theorem. So r equals the square root of x squared, so 3 squared plus y squared, which was -4. Okay, and I'm just going to clean this up as much as I can. So square root is still there. 3 squared is 9. -4 squared is 16. Cleaning up some more. I have the square root of 25, which is simply 5. So my radius is 5. Now I'm able to use these rules that we just talked about right here above on your notes. I'm going to do my 6 right triangle ratios. Okay, so let's start off with sine. So for this example, I'm just going to do it beside each one. Up here, it's y over r, so I have 4/5. For cosine, it's x over r, or sorry, that should be -4/5. For cosine, it's going to be x over r, so 3/5. For tangent, it's y over x, so -4/3. And then for cosecant, it's r over y, so it's going to be 5 over -4. And then for secant, it's r over x, so 5 over 3. And then finally for cotangent, it's x over y, so 3 over -4. And that's really all there is to it, no big deal. You just have to do a little bit of calculation to find your radius if you're given the point using the Pythagorean theorem. Alright, now we're given the angle. We want to find these 6 trigonometric functions of 180 degrees. I'm going to start off by drawing a sketch. So here's my coordinate plane. My angle for this to work has to be in standard position, so I know the initial side is on the positive x-axis, but I also know that 180 degrees is right here, so my terminal side is right here. Okay? Now, I'm not told a point, so I'm just going to pick a point. What should happen, regardless of the point, all these ratios should be the same, okay? Or sorry, it shouldn't be the same because the radius is going to be different. For instance, if I picked -1, 0 versus -2, 0, the ratios are going to be similar, but they're going to be multiples of whatever the radius is. So let's do it. I'm just going to use -1, 0. You can pick whatever point you want. You can pick -2, 0, -3, 0, -1/2, 0. As long as it lives on this terminal side of the angle and it's not at the origin, that's fine. I'm going to do -1, 0. You use whatever point you want to use. It should be pretty similar, but again, yours might be just slightly off based on the multiples of the radius that you find. Alright, so again, I'm using negative 1, 0, so that is my x and my y. So based on that point I'm using, I'm going to calculate my r. So r equals the square root of x squared plus y squared. And my r is then, if I plug in, negative 1 squared plus 0 squared, which is going to be the square root of 1, which is 1. So r equals 1. Alright, so now I'm going to start off with sine. So sine of 180 is going to be, based on this, the point that I'm using, sine of 180 is going to be my y over r. So it's going to be 0 over negative 1, which is simply 0. Cosine of 180 is going to be x over r, so negative 1 over, so it's x over r. And actually I messed up here, my r is positive 1. I don't know why I put negative 1. It doesn't really matter because 0 over 1 is still 0. Sorry, I just caught that mistake and had to fix it. Cosine is x over r, so we have negative 1 over 1, which is going to be negative 1. Tangent of 180 is y over x, so I have 0 over negative 1, which is going to be 0. Alright, now I'm doing cosecant of 180, which is r over y. R over y, so my r was 1, my y was 0. But this is undefined, because you cannot have 0 at the bottom of a fraction ever. So the cosecant is undefined for 180 degrees. Alright, now I want to do secant. That's going to be r over x, which is going to be 1 over negative 1, which is negative 1. And that was secant of 180. Now I'm going to do cotangent of 180, which is x over y, which is going to be negative 1 over 0, which is undefined. So again, you cannot have a 0 in the bottom of a fraction, so it becomes undefined. So if I use my calculator to verify some of these, and again, it all is based on what is your r. If I pick the point negative 2, 0, my r value would be different, so these would just be multiples of whatever your radius is. But should be, besides that multiple, it should be fairly similar process. So I'm going to just do, first off, I'm going to make sure I'm in degree mode, because that's what the problem gave us, was degrees. And I'm going to do sine of 180. Is 0. Cosine of 180 is negative 1. Tangent of 180 is 0. So far we're good. Now let's do cosecant. Remember, cosecant is simply 1 over sine, so 1 divided by sine of 180 is undefined because we're dividing by 0. You can't do that. And again, there's no cosecant, secant, or cotangent buttons on your calculator, so you have to remember that. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent is the reciprocal of cotangent. So you got to remember that. All right, 1 over cosine is the secant of 180. We got negative 1, so that's good. And then finally, 1 over tangent of 180 is the same thing as cotangent, and that's also undefined because we divide by 0. Now, talk about the calculator. Everything worked out perfectly with what I did because I chose something that gave me a radius 1. Your calculator is automatically by default set when it does the trig functions. It thinks about it in terms of radius 1. So if you pick another point, say negative 2, 0, and you check it, it might not come out to be the exact same thing because your calculator is defaulted to radius 1. So you got to keep that in mind if you're going to use your calculator to check. Other than that, that's it for this video. Let me know if you got questions.